Okay, and our webinar has officially started.
I was telling Borhan it was a little bit difficult for me to find the link on the website.
I know, it's not as easy as I would
Just
like it to
hoping
be.
people can find it and join the meeting.
Yeah, I know that our council liaisons sent it out with the direct link, which is great. So they shared directly to the Zoom. So for anyone just joining, we will be starting just shortly after 5. So just sit tight for now and we'll kick it off in a little bit here. For everyone just joining, we will be starting in a little bit, probably just after 5 o'clock. So just sit tight for now and we'll get started in a little bit. So it is almost 5 o'clock. We're probably going to give people till just a little bit after 5 to allow for some room for other people to join. So for now, just sit tight and we'll start soon. It is 5 o'clock. We're gonna let the clock run till about 5:02, and then we'll get started. So for everyone who's just now joining, please sit tight for just a little bit longer, and then we'll begin our presentation. All right. It is officially 5:02 according to my clock, so we're going to go ahead and get started. Good evening, everyone. My name is Renee Plave. I'm just going to do a quick little intro for you to let you know a couple features of the meeting. So our staff members from Power Delivery are going to be conducting this meeting. They'll give a great presentation on the PDMP, which is short for Power Delivery Master Plan. And I just want to go over a few housekeeping things. We will be taking questions, but not until the end of the presentation. If a question does come up to you, though, in the middle of the presentation, you want to get it out, jot it down. There are two ways that you can ask questions, either in our chat function. You're more than welcome to put information in there, and myself and the other staff members will see it. You can also use the Q&A function, which is pretty similar as well, and it just allows you to type in your question. So again, at the end, we will take questions. We'll have a little Q&A session and have more opportunities for feedback. So with that, I'm going to go ahead and turn it over to our Assistant General Manager of Power Delivery, Mr. Marvin Moon. Marv, you can take it away.
All right, thank you so much, Renee. I also want to thank all you folks for coming out tonight on this virtual public meeting. This, of course, is about regarding the Power Delivery Master Plan for Water and Power. And let me just frame it, see what this is. It's basically a 20-year roadmap on what we need to do in the power delivery side of the business to keep the power flowing reliably and economically, knowing that things are always changing. The whole industry is changing. We have things that we never even dreamed of, maybe 20 years ago, such as solar panels, electric vehicles, and battery systems, and other things like that. Plus, the way we do our business isn't the same either. So all that to say is that this is a document that we have that gives us the roadmap of what we need to do, what initiatives do we need to do, not only to keep it reliable, but also such as how do we plan for things? How do we make things better? For example, like automated metering infrastructure or smart metering. How do we make a smart grid to give more customer options available? How do we solve some of our power flows that we have, power flow issues in the system to make it better and more reliable and redundant? Those are the things you're going to hear about tonight in this presentation. And let me just also say that in the power system, there's kind of like two big divisions. There's people called the power supply division and then the power delivery division. The power supply division, those are the folks that basically figure out where we're going to get the power. What's the recipe? How much renewables are we going to have? How much solar? How much wind? How much are we going to buy on the open market? They're the guys that figure out how we get the power to the city. Once it gets to the city, that's where power delivery takes over, and that's where we have to have all the way of delivering the power to all the customers that's reliable, and when you flip that switch, it's going to work. So that's kind of the big distinction. You're going to hear a lot about the delivery part. Delivery is also a little different than the supply side. The supply side just talks about how much power they have to deliver. On the delivery side, we have to hit the peaks. If everyone turned on the air conditioners at one time, we have to be able to deliver the full power. When people need the power, we deliver it. And that's what this plan addresses. And not only delivering the power, but also we have several thousand solar systems now in town, and that power now comes our way. We buy power from customers and then they buy it back at night. And so how do you deal with that? That's the kind of things that we have to address in this plan. This plan has actually taken about 2 years to do. We had a public meeting about 2 years ago when we started this thing. And the whole purpose of this is to gather feedback to make sure we have a plan that's responsive to the community. Our plan after this will be going to the Environmental Committee, Commission from City Council. We'll go into the Municipal Services Committee. Actually, we're going to go twice, first time for comments, and second time with the final plan. And then we'll eventually go to City Council after that for final approval. And then it's just a matter of acting on the plan. So this is a great plan. We have a couple folks with us today. We have our engineering manager, Varuj Navedian, and our planning manager, Borhan Astani. He's going to be giving the presentation. And so with that, I'm going to turn it over to you, Borhan, and take it away.
Thank you very much, Marvin. Good evening, everyone. I'll be happy to present our draft plan for the next 20 years for Pasadena Water and Power. In this plan, I'm going to be giving a high-level review of the report. And I received a question actually in the chat that about if we are going to publish the draft. So we will have a draft up on the website just before the MSC meeting, which is going to be on April 12th. So you'll have it available at that time. So traditionally, the power is imported to the city of Pasadena or maybe generated internally from outside world. These power plants, or right now we have solar plants or windmills. So they come up and they from outside the state, they are generated, stepped up, transmitted over the grid, and enters into our city. So we have, starting at D level here, we have, this is our first station where we receive power. And then the voltage is stepped down to a level to distribution stations. And then one more time step down to a level where we distributed to our homes and businesses. And this is kind of, it was a one-way power system, like from generation to the customer. Now we are in a new grid of new technology or microgrids that where we have technologies like solars, battery storage, so all in place within the city boundaries of Pasadena. So we were going to take care of it, and this plan addresses these changes and these advancements in technology. In Pasadena, we're serving our customer over 23 square miles, and we have about 67,000 services, whether they are commercial services or residential services. And we're just looking at it. It's about the majority of our services goes to our residential. However, most of the load goes to our commercial, even they are a small percentage. One of the things that we are proud of is our mission as Pasadena Water and Power. And then our mission basically is our commitment to provide a safe, reliable service to our residents and constituents in Pasadena. And we'll try to do it the best we can with a very reasonable prices. While we are developing the plan over the past 2 years, we developed 5 categories, like our primary goals. And then we put them there to make sure that our business or our performance for our residents stays top notch. The first category that we put in is reliability, and this is basically the core of our business, or a core of our plan goes around it. So in this plan, we designed our projects and our plan to go around reducing the outages so our customers do not experience outages. And if they do, we also planned to reduce the duration of these outages. One of the key goals that we set there is to replace our aging equipment or maintain it in a way that we maintain the high level of service that we have. Of course, we are taking into consideration when we have heat waves, wildfires, or windstorms, that we need to reduce the risk to our residents. So the second reliability, or just the second primary goal that we set for ourselves is resiliency, meaning that we need, in case of any emergency or any contingency that we have, we're able to recover quickly and restore our services to our residents. And then one of the issues that we have, and we'll be talking more about later on in the projects and the solutions that we're providing, is the flow within our system, especially at a high level voltage, or the import capacity, how much we can import from outside the city, from the regional grid or California grid or US grid at large. And then we were thinking also about bolstering our imports by adding a new connection to the city of Los Angeles, where this was the original interconnection between Pasadena and Los Angeles just before 1970s, where we switched to the other side, where we have larger capacity or bigger capacity to import. So we switched to Southern California Edison interconnection. The third category that we put our primary goals is under power quality, meaning that we want to make sure that when you turn on the switch on a power switch on your house or your business, you have power and you have the voltage level within a certain limit that is being recommended by IEEE, which is the Institute of Electrical and Electronics Engineers. So also in the third category, we put in the modernization of it. And we talked about having solars and battery storage, fuel cells. And then in order to make sure that all these components work cohesively, we want to make sure that our protection system is upgraded and has the state-of-the-art equipment, and that will help us a better or give us a better monitoring and controlling of the system components across the system. And that will also help us introduce the automation of our distribution system. The fifth and last component of our primary goals, it's going to be touching our residents directly while we implementing an advanced metering infrastructure. And that will help the customers and us at the same time. It will help customers design or just kind of choose their billing kind of schedule, the time of use schedule. And it will help us as a utility to plan how to size and how to upgrade and how to cope with issues that we face or we see over the system. And also, we are noticing the new trend that for the cars and the new electric cars or vehicles going across the country. So we are introducing a lot of charging stations across the city to help our residents and visitors to have a charging station anywhere in the city. So that will help also us in generating more revenues for the utility. One of the things that industry measure itself how good the performance of utilities is an index called System Average Interruption Frequency Index, in abbreviation as SAIFI. And then basically that it translates into how many outages and a customer experience over a certain period of time. Usually it is over 1 year. And then this chart shows a comparison between Pasadena and our sister utilities, whether Glendale, LA, Riverside, Anaheim. And then we compare ourselves, how we are performing in comparison to them. Pasadena here actually shows in gold. And then we noticed that we outperform all our the sister utilities in a much, and actually it's noticeable that we are outperforming them. So it doesn't mean that they are bad, but it's where our numbers are really outstanding. We set a goal for ourselves that is 0.31, meaning that any resident in Pasadena would possibly, we want him to experience less than one outage every 3 years. And this is a very high level goal. Sometimes we achieved it many years. Achieving it is really important. Maintaining it and keeping it to that level is really a challenge for any utility to keep it. And then we're putting up with it, and we're willing and we're working to maintain that goal, or our outage, our performance under that number. Of course, the lower the number is, like 0.31, the lower the number is the better performance level for us. The other index that we used to, like, as a electric industry to measure performance is SAIDI. And then if we experience an outage, how long the outage lasts. And then again, we're kind of very much outperforming all the utilities except Burbank. But there is the catch with Burbank is that they have an overhead system, so it's easier to control and maintain compared to our system, which the majority of our system is underground. So with underground, it takes longer time to discover where the issue is and where the problem, and it takes longer time to repair. But we're still outperforming other utilities with the same kind of structure like our system. We set a goal for ourselves to maintain the unplanned outages to be under 35 minutes. And then we're working on it. Again, it's a very high number. Across the country, these numbers, most of the utilities, they go up to 120 minutes, but our numbers, where we set our goal is really high as 35 minutes. And then of course, the lower the number that we produce is the better for as a good indicator for our system. Over the past 10 years, we track how much or the demand on our system. And then looking at it, the all-time peak happened in 2010, and the number keeps fluctuating up and down. And usually that depends on the level or just how we cope, or how the hot summer or the heat waves impact the city, and of course the demand on our system. And then I know just in 2021 we have like a unique year there, or a unique summer, where we really have a really mild summer. We didn't have that much of a heat waves. That's one factor that put the peak down. The other one is a stay-at-home order by the state of California because of the COVID-19 coronavirus. So that's also just reduced the load on our system. And of course, because a lot of schools, businesses, they were closed, so we didn't have much of a electric usage at that time. And also another contributing factor to it, which is going to be talking about a little bit more, is also having more solar systems and more fuel systems are installed within Pasadena. That of course reduces the demand on our energy that we import from outside. If we can go back and talk about our system, where we import it, and on what kind of the sources for it. As general, just we're not discussing about the source itself and what type of, where we get what type of energy produced by what system, but we are talking about generally where we receive the energy as a bulk energy. The main source comes from our interconnection with a station, with a receiving station at the east side of the city called TM Goodrich. And then we have a physical limit on it right now, and that's one of the issues that we are tackling in order to remove this limit. We have 280 megawatts right now, but our contract with Edison and CAISO, California Independent System Operators, to import up to 336 megawatts. The second source of power within Fort Pasadena is our power plant, where we can generate up to 200 megawatts. The third connection, or just that's which is still on a standby, we can receive up to 40 megawatts of energy from Los Angeles once connected. We have an issue with this one. This is also, we're proposing a solution to it. Our system is not electrically compatible with the city of Los Angeles, that we need to install a transformer, we call it a phase shifting transformer. So to adjust the power received from LA to have a match with the electric system that we have, so we can import from Los Angeles. Right now, this one is not connected. It's on a standby. It's on a standby status, and just kind of we use it just in case of emergency if we have a complete blackout, which is we're lucky that we never had this one before. The fourth source of energy to residents of Pasadena are internally too. As I mentioned, Errol, we mentioned many times that we have the solar system that installed within city of Pasadena. We have about 2,000 installed, whether they are city owned or customer owned or business owned. We can generate up to 19 megawatts. And then also we have about 11 customers who can generate up to 7 megawatts of energy or power within the city of Pasadena, the boundaries of city of Pasadena. And we're talking about right now about the generation of solar systems. And this graph shows the increased number of systems as well as the power that it produces. The blue one for solar system, the gold is for the fuel cells. And then by the end of 2021, so there's about 19 megawatts generated by solar systems. There's about more than 2,000 systems installed. And there is about 11 systems that they can generate up to 7 megawatts of energy, of power from 11 customers. The picture here shows that our Windsor Reservoir that is owned by the city of Pasadena, that's a solar system that generates more than 500 kilowatts of power. This is the trend, and another trend that we see coming up in our borders is the usage of electric vehicles. And then here the graph shows the increased number of electric vehicles, or full electric vehicles in the green, and the plug-in hybrid ones in blue. And then you see that the fully electrical cars are just outpacing the plug-in hybrids. And then we are about, by the end of 2020, the registered cars are about more than 2,400 cars, and we expect the trend to continue in this manner. I was reading an article a couple of days ago, and then the sales in California, the electric vehicles, they are kind of at certain areas, they are more than 12%. The picture here, it shows that our Arroyo electric vehicle charging station, this is at the west side of the 110 freeway entrance that you can see it. You can, if you have an electric car, you can drive in and have your car charged there. This is a project that we're planning to do, or we are interested in to implement, where there is where these projects make sense. On the picture on the left here, that's for an overhead battery storage project that we are basically producing, and we're about to implement. We're updating the firmware from the manufacturer, and then once it is done, we're gonna go ahead and install it. And these kind of projects, very much similar to the one on the other side, the one in the middle, these projects will help mitigate the conditions during the summer peak time, where we have a lot of demand on electricity, and then we have a lot of our residents or services that are turning on their AC units, so that these will help mitigate these conditions. In addition, these projects will help us also deviate or just some capital improvements, and just push them a couple of years forward. So by reducing the load on the main cables or the transformers, that will help balance our budget and stretch our dollars. On the lower corner here, this is a utility scale project. Right now, actually, the city of Pasadena is looking into projects like this and considering them. They're our power supply group they're about to start a feasibility study to see where and how to install and implement these utility scale distributed energy resources. Okay, so this what we talked about right now are the factors that that has a direct impact on our system load. We talked about the DER, distributed energy resources, the electric vehicles. The building electrification is a program that the city considering to encourage our resident to start having electric like equipment or just electric devices in their home, like dryers, stoves, so that will support the clean energy, the clean air initiatives. Also programs, even though they were asking the customers to use electric equipment, but at the same time, there's programs to help customers also reduce the usage of the electricity at the same time. And then also the factor that mainly affects the projection or the forecast of the load is the typical customers, like new businesses coming in or out, or new apartment buildings or a house adding a new solar that reduce their usage, and so on. This is a graph that shows the prediction, but let me just kind of explain what does this one mean. The goal line here shows the projection of our load as if there are no electric vehicles, no solar systems, no battery storage, no electrification, no programs, nothing, just only like 40, 50 years ago. That's only straight electric usage from the power plant to the customer, to their washers, dryers, or fridges. So that's the straight projection. Now, if we start adding the factors that impact our system, like for example, if we add the electrifications or the programs that we do, then you're looking at the dotted line. Our load will look like the dotted line. If we introduce only the battery storage on solar systems, then we're talking about the dashed lines. If we only talk about the electric vehicles, then we're talking about the dashed green line. But if we combine all of them together, we'll end up with the thick red line. That's our projection for our system peaks for the next 20 years. And of course, this will change. It's not going to be like final every 3-4 years when our group redevelop their resource plan. Then these numbers will be revised and adjusted accordingly. And again, we talked about the peak here in 2021, why this we have these low peak here because of the COVID impact and then the businesses and schools. Here, another impact that we are going to have an increase on demand on our system, which is basically one of our large customers. They're going to be shutting down their generation facility, and that will add about 8 to 10 megawatts to our system. So because they will need to renovate their system. So by the time they're doing that one, we're going to pick up their load. And then again, we talked earlier about we have a lot of system limitations, and then the plan here provides a solution for it. One of the limitations that, or one of the major limitations that we have, is our aging infrastructure. And then one of the components of our infrastructure are the substation transformer, which is, these are large units. We have about 30 of them. Sorry, there are 15 of them. They are distributed around the city in 11 distribution substations. And then when we say a unit, we mean about 2 transformers and the related switchgear in between them, whether the protection system or the switches themselves, to reroute the power. So these are our the 15 units of them. They're aging, and many of them are beyond or more than 50 years old, or some of them are more than 60 years old. So those are just kind of, they reached the end of their useful life and then need to be replaced before a major issue or accident happen with them. So our plan or propose is that we replace one unit every 3 years, and then we are doing conversion, or we're doing some other projects. We are also proposing to remove one unit every 3 to 5 years, depending on the voltage conversion project that are going to be executed across the city. A second limitation, I touched base on it, which is the import capacity. And then we said our contract with Edison is to import up to 336 megawatts. And right now, because of limitation with the physical limitations of the transformers or the distribution system, or the, let me go back here, the sub-transmission system that we have is restricting our import to 280 megawatts. And of course, coupled with some conditions, electrically, we restrict our operating conditions, where we cannot put the 3 transformers at the receiving station at the same time. So what we do, we propose to add, to upgrade our existing transformer with larger ones, and at the same time add some devices or electric equipment that reduces what we call a short circuit duty, or the short circuit current, that that will prevent us from operating our system all at once. And then when we do that one, we want to make sure that the short circuit duty within the system is less than the rating of the equipment installed. So if any fault happens within the system, we do not cause any damage, or that short circuit does not cause any damage to the equipment within our system. Another limitation that we have, just kind of, this is also another one that that restricts the flow of our energy from within our system once we import it or regenerate it, either way, and that's our sub-transmission system. The conductors there, the conductors and the size, the size of it, meaning the ability to transfer power, the capacity of it is lower than we want it to be. It's been in service for 40 or 50 years ago, and that where we have less demand on electricity. So it was properly sized for that time, but not for this time. And in the age of it, many of it is more than 40 years old. And that also at the same time, our protection system, we have a lot of electromechanical equipment that need to be upgraded, that need to be to the new, like to follow the trend of the new technologies that we have. It helps us monitor and control equipment and then recover faster in case of any emergency or any faulty conditions. So what we are proposing and to mitigate this this condition is to upgrade our sub-transmission system, one sub-transmission every year, and then also to the protection equipment. We upgraded on both ends of the transmission line, sub-transmission line at each station. I'm just going to elaborate on this one and then tell you exactly how we plan or propose to upgrade these upgrades to our cable system, because it's really without these cable system, which is the backbone of our system, we don't have enough capacity to deliver the power from the receiving station to the distribution stations. As I mentioned earlier, this is our main interconnection with the outside world, which is at Edison. And then we have the local generations here, and then our standby connection with Los Angeles, and of course we have our solar systems all over the city. So the issue that we have is the cables at this red line here. Red line here, if you see on the right side here, the picture that shows that shows the impact of aging and the compact condition, the way they were installed in the previous time. So we see that all of them like aging, they're next to each other. We cannot replace them at the same time because they especially when they are energized. In order to replace them, so what we need to do is we need to upgrade these lines were highlighted with yellow. We call this one as path 3. Path 3 lines, which is goes to the distribution substations, which is these are less number of conductors and with less capacity. But in order to upgrade the line, the subtransmission lines in red here, we need to upgrade these subtransmission lines and the protection system around them to allow us to upgrade the subtransmission lines in red. But the period of time that we choose is winter time. Why winter time? Because it is the lowest condition or the least load on the system. So that's where we be able to transfer all the power through these yellow lines. So in the first 5 years, we'll be upgrading these lines here. And then next, we'll be upgrading the lines here, the 4 of them here. And then in the future, if we feel that we need to electrically split the system or just by adding a new devices to reduce the short circuit current, we might need to upgrade these conductors in green color. But right now, these are just kind of on a standby. We didn't say that we need it right now, but in the future, maybe like after 10, 15 years, we might consider it if we upgrade and we do electrically split the system. This is a map of Pasadena that shows 2 colors. And these colors, each of them represent the voltage current that for the circuits that serve the neighborhoods within Pasadena. The green one, they are 17,000 volts circuits. The brown one, they are the 4,000 volts. The 4,000 volts, they were originally been in service for a long time, from about 60, 70 years ago. But now we feel that the need of having the 17,000 volts, because the ability to transfer power, to carry more customers, to carry more energy to the neighborhood circuits is 4 times using the 17,000 volt system than the 4,000 volts. So that's in the past 5 years, we were doing a lot of project within this area, this circled in blue. We're converting the service voltage from 4,000 to 17,000. When I say the service voltage, I mean the primary side, which is our side, the utility side. Customers usually do not see the changes because they are served by 120 to 40 volts. They don't see it, but on our side, that's where we do the changes. And of course, when we do the changes on the circuits, we do change the secondary conductors that will boost in the voltage at the customer panels, that improve the power quality, less fluctuation, and more stable voltages. And the next 5 years, we will be focusing on this area on the northwest side of the city. And again, we will be converting the areas in the shaded brown into green areas. And then while we're doing that one, there's a lot of project also in this area will be done, as well as the other cities where we're going to be replacing a lot of equipment and infrastructure, whether they are poles, transformers, switches, adding more volts or trenches or just conduit system all over the place. So but a lot of project will be conducted in this area. One of the projects that we'll be doing will be adding a underground system from the borders north of the city to the up to the freeway, to the 210 freeway along Raymond Avenue. We will be also replacing, as we mentioned earlier, we're going to be replacing substation units. That's basically 2 transformer and the switchgear. So they're going to be replaced in the Fair Oaks substation, as well as we're going to be converting some circuits from 4,000 volts to 17,000 volts. So all this will be coming in the next 5 years. And of course, after these 5 years, we'll be doing some other project either within this area or different area where is the most needed within the city. Okay, this is this graph shows a kind of the first 10 years of the projects and the dollar value for these proposed projects. I'm going to start with like explaining a couple of them, but I want to mention that the light blue bars, they represent the typical project that we do every year over and over, whether they are replacing equipment, upgrading transformers, or replacing switches, replacing cables, poles, you name it. All these components are included into the light blue colors. And then I heard, just like we mentioned, that for grid modernization goal, the primary goal, we mentioned that we will need to replace our meters with a new advanced meters and advanced metering infrastructure. Those, if you look at the red bars here, within the first 5 years of this proposed plan, we're going to be replacing the meters within the city. And that includes the meters, their communication, the software, and of course, training our staff to use them. Those kind of, this project alone, that's about $41 million over the next 5 years. That's about $8 million per year. And that's why you see these jump over the blue ones. And if you look at when we mentioned about upgrading the cables, the path 3, if you recall, that's the path 3, the yellow chunks here. That will start with 2.7 next year, 5.8, 5.8, 2.7, and that goes on. Those are just the ones that we never done that magnitude of projects before. We're doing it in a sequential order again, and you see the purple ones. That's the other one that I showed in red. So these are going to be done in an order, in a sequential order, to have the best benefits from these upgrades. And of course, I want to make sure that our eyes also execute them in the wintertime with the safety, with a major concern for the safety of our customers as well as our employees. So the other project that we're talking about and we're going to be doing and we didn't do for the last few years, which is undergrounding project, where we convert our overhead system into underground because we feel that reliability of underground system outweighs the overhead. So these are projects that are going to be introduced like coming in fiscal year 24. So we're going to have project here in the brown color. Some here also we mentioned also in this red circle when I said the Fair Oaks upgrade, these 2 blue ones are more projects, I think, replacing conductors or transformers, and it will continue with the others. And so that's why all these projects are structured in a way that we get the best benefits of the dollars and the stretch of these projects for just to reduce the cost and the duration for these projects. This is a very lump sum of all the projects. The total projects that we proposed are $223 million for the next 5 years, $480 for then from year 6 to year 20. The electric service connection, these are usually reimbursed project. Usually we construct project for the benefit of customers, and then they reimburse the city for these projects. The total for them for the next 5 years we expect it to be $250 million on an average $15 million per year. If we compare it to the expenditure for the previous 5 years, on average, we were there about almost $34 million. But again, the difference in between them for between 50 and 34 is about first $8 million per year for the advanced metering infrastructure. There's about $4 million for the undergrounding system. And there's also about two million. Okay, I can go back. Hold on, if you go back 1 minute. And there is also the cable, upgrading the underground cables for the subtransmission system. That averages about $4 million per year. So that's by about four for the cables, 4 for the underground, and 8 for the advanced metering infrastructure. That's about $16 million. When you add them up, they're almost the same average level what we spent over the past 5 years. We believe that the employees that we have, the staff that we have, the number of employees is adequate to complete these projects, and we'll make sure that all employees, if any of them leaves for retirement or picks another job somewhere else, that we replace them with another employee. And at certain times, if we feel that we need help, we can go outside and have contractors come and support our work or the completing the projects. Funds, usually our plan is usually revised every year. Projects and budget is reviewed every year, and also it is approved by the city council. We have to take our budget every year to the city council. Resources for these projects, it comes from the funds generated by selling the energy to our clients, whether residential and commercial customers, as well as some grants from the federal government or the state. This is like a table that shows that it's a cross-reference between, or just kind of the relationship between the projects that we propose and the primary goals that we have. And I'm going to pick one of them. Let's say if we say the substation upgrade unit, when we do that one, we replace transformers, so we have a newer equipment, and then we do also help in the grid modernization. We use new relays, new circuit breakers, and new applications. So we have a better view and control of our system. So we modernize our system. When we upgrade the units from 4,000 to 17,000, we have more strength to our circuits, so that can deliver power for longer distances with less voltage drops. So power quality for customers will be improved. And then of course, we have more of 17,000 volt circuits. We can switch between them in case of an emergency. So we have more resiliency between the distribution system as well as the and the 34 kV system, which is the subtransmission system. If we pick, for example, the 4 to 17,000 kV voltage, which is 4,000, it's very much the same argument or the same explanation, that we're going to have new equipment. We have the stronger feeders. They can give you, or just can deliver power for longer distances, and so on. And that's why this is a good for reference for anyone who asks how this project helps achieve the goals for the plan. As Marvin mentioned earlier in the introduction, we're having this presentation today. We have next month we're going to the environmental agency, and we'll be presenting this plan to them, as well as the municipal service committee on the same day. And then we'll go back again, ask for adoption of this plan, and then we'll take it to the city council for the final approval. And I believe that we are ready to take your questions or
Sounds
comments.
good. So just as a reminder, everyone, if you do have any questions, I know we've already had some come through. We're going to start tackling them. But if you haven't already asked a question and you'd like to submit one, or even if you just have feedback or comment, you can use the chat function or the Q&A function, and we'll be more than happy to get to them. So with that, I'm going to go ahead and get started. And as a reminder, we did have a question that came in at the beginning, which was, can we download a copy of the plan? Can we view the plan? And as Burhan mentioned, we will be posting it on our website. But that will be closer to that MSC meeting, which I believe Burhan said is April 12th. So with that, the first question we had was, how will you address distributed generation from net metering? Will NEM continue as currently?
I'll address that one. All the utilities back in, it goes back quite a while, almost 20 years. There was a law, state law that said that they had to offer a net metering program until their load reached 5%. Pasadena's reached that now. For us, that'd be about 15 megawatts of solar. As you saw in the presentation, there's about 19 megawatts. But before we could even look at if our rate is fair to everybody and if it's the right formula and mix, we have to do a cost of service study just to see exactly what each of the residential and commercial and other types of customers pay, so that there's no cross subsidization. So that has to happen first, and then eventually we'll be addressing the net metering rate to see if it's still appropriate after all these years.
Great. So the next question we had come in is referring to when we were talking about our energy sources, and Burhan, you mentioned about some of the ones that our customers are producing, and specifically the question is, what fuels do the fuel cells use, and specifically that 9 megawatts reference that you had?
That's, if I may.
Right.
So that's typically natural gas that the fuel cells use.
Thank you, Verision. The next question is the overhead storage for DER a pilot project in just one location? This participant finds it very interesting, would like more information.
Well,
Sure.
go ahead.
Okay, go ahead, Burhan.
No, actually, our pilot project, we're going to have about 15 cells. They're going to be installed on one circuit. And then based on the results, how it's going to impact the loading and the performance of these batteries. And then we'll decide if we're going to continue with this project or not.
Yeah. And let me just add that this project is very unique. I don't know if anybody doing it the way we're doing it, because this installing these batteries on the poles defers a very expensive upgrade. In fact, it's 80% cheaper than the normal way we solve these problems. So we have a lot of it's going to be a great learning experience for us. Like you said, the battery systems are about ready to go as soon as the firmware is updated. And we even got a grant from the American Public Power Association so we could share the results with other utilities.
Thank you. The next question is regarding the graph, Burhan, that you showed that had those multiple lines of our forecasted load. The question is, on the PWP net load forecast slide, why is the DER forecast flat? Seems likely that there will be a lot more rooftop solar and microgrids and community solar. So if we could answer that question about that graph. That's the one. So I believe she's referring to that purple
Yes.
line there.
Well, because, the solar introduced generates power. The storage. Well, actually, that's I don't know. Can you let me go back to the question one more time?
Yeah. So the question is, why is that purple line, that DER forecast, flat? Seems likely there will be a lot more rooftop solar and microgrids and community solar.
Actually, what it's saying is that because of solar, the yellow line, which would have been if there was no solar or nothing else, it actually pulls it down because it's providing power that the utility didn't have to buy from outside of town. So that's why it's on the low end. the green line, like the EVs on top, that's adding load. So that's why it's on the top. So between the solar pulling the net load down and the EVs pulling it up, the red kind of is kind of flat. So that's what's happening.
Yeah.
And also just to,
yeah.
Sorry, Bob.
Go ahead.
Just to kind of, I see the confusion. The purple line is not the DER per se. Maybe the labeling could have been better. But the purple line is basically what Marv said, is the load if we had basically just the DER impacting on our system.
Yeah.
Thank you all. The next question we have is, what assumptions go into the 30 megawatt load for EVs? Is everyone charging when they get home from work, or do you assume you can persuade them to mostly charge overnight?
No.
No.
I can address that. When we did this load for this study, we looked at all the modeling as far as how much adoption we expect to see in the city. And the good thing about electric vehicles is that, you know, residential charging that's where 80% of the charging happens. And then 80% of that is off peak. You know, obviously in the middle of the night, people plug in and it's all full in the morning. And every electric vehicle in town has a consumption of about half a house. So if you have 10,000 electric vehicles, that's equivalent to like 5,000 residential units. So it's a lot of power, but the good thing is it's at night. Now, obviously, we don't want people to come home right when the sun goes down, all the solar went away, and plug in their vehicles. You know, right now it's not that big a deal because the number of cars is kind of low, but when that number gets big, that could be a big deal. The number one way to encourage people to charge off peak later in the evening is through time of use rates, offering discounts to charge later in the evening. And a lot of utilities have that. And when we do our automated meter infrastructure program, our smart grid program, that'll open up a lot more rate options where we can do things like that. So that's how we plan to address it.
Thank you, Marvin. The next question refers to, Burhan, I believe the specific phrase you used is you're going to be replacing one line per year. And so the question is, for the 35 kV system, what do you mean by one line per year? If you could elaborate on that.
Sure. Okay, and this.
So while Borhan is bring up the slide, one line refers to one sub-transmission line.
Yes, okay, so this one here, the red line I have here, we put it one, but actually this is, we call it path 2. There are 4 circuits. So when I say one line, meaning one circuit, and each circuit consists of 8 conductors per phase. I mean, sorry, that the circuit, each circuit has 2 runs, basically two for 3 AM. Okay, let me explain better. In an electric system, we call it 3-phase, A, B, and C. So for A, we have 1 conductor. For B, 1 conductor. For C, we have 1 conductor. That's one. We call it one run. So for this red line here, we have 4 circuits, and each circuit has 2 runs. So basically, we have 4 circuits, and each circuit has 2 runs. So basically 8 conductors per phase. And I don't know if I made it easier, but
Maybe I could just say also, if you look at the blue lines, those are typically just one circuit, one end or one line. So for example, this year we might do the Chester to Glenarm receiving station line. Next year we might do the Villa to Glenarm receiving station line. Eventually we change them all, but it's one blue line per year. And then after all those are upgraded, we get enough flow going through that way, then we can attack the red line. But the red line's 4 circuits, so that's like a 4-year job, you know, a little bit every year.
And kind of to put it in a different way, like with roads and highways, imagine the red is your freeway. And we have to, in order for us to shut the freeway down, we have to build up our local roads to basically reroute the cars through the local roads. Those are the blue lines that Burhan was showing. So we have to first do that in order to basically shut the freeway down, the red line down to replace it.
Thank
I
you.
want to show just kind of a little bit, explain it a little bit more. Okay, so like here, I know I know the picture is ugly, but don't worry about it. So here, let's say when we say we have 4 circuit like this set here on the top, and I'm giving numbers. I'm not accurate in this one, just to show you what I mean by 1 circuit or one cable. This is 1 and this is 2. These are, we call them 1 circuit. So, and this is another circuit. And on the other side of the vault, there is another set like this. So this is one line, and this is another line. That's what we mean by it.
Thank you. So the next question is referring to our AMI. And the question is, are you implying that in 5 years, if we adopt the PDMP plan, in 5 years, all customers will have AMI? Is that correct?
That's the goal.
That's the goal.
All right, great.
You know,
thank you.
obviously, we couldn't even do AMI without a new customer information system, billing system. And that's going live next month. Let's put a lot of work into that. But that's what enables that to be able to take AMI meter data and send it and properly bill it. You have to do that first. So that's winding down, almost going live next month. And then we'll have to do a needs assessment as far as what exactly what kind of system do we need, and then work towards getting the system. But again, it's going to take a few years to get it.
Thank you. The next question is also involving AMI, and it asks, how will advanced metering infrastructure affect NEM and rooftop solar in Pasadena?
Well, the one thing about advanced metering infrastructure is that it opens up a whole bunch of possible rate options. I mentioned time of use for electric vehicles. It can do that. It can handle more fancy ways of handling net metering. So that's the enabling technology to open up new rate options.
Thank you. The next question is asking that the CPUC is working on NEM rules. Is PWP not under CPUC jurisdiction?
And no, that the CPUC is working on NEM3 for the investor-owned utilities, which are Edison, San Diego, and PG&E. We are under the city council's jurisdiction, and so any changes to NEM or any rate structure would be going through a public process here in Pasadena with, of course, a local jurisdiction.
Thank you. Another question is, how are we preparing for emergency power needs, specifically increased wildfires across the state and increased temperatures due to climate crisis?
Mm-hmm. Oh, that's a good question. One of the things we've done for the last 2 years is we have actually we had one before that too, but it really got pretty rigorous the last couple of years. We have a wildfire mitigation plan, and it systematically looks at the risks that we have in a city and ranks different parts of town as more risky than others. The highest risk areas, of course, are, obviously you would think in the Northwest and the Northeast, up next to the mountains. And we've identified, we've done a number of projects already to help mitigate the risk of fires. For example, Millard Canyon, the wildfire area in the Northwest area, we've converted a primary line up there to low voltage. We went from thousands of volts down to 240 volts. So that was a great opportunity to reduce the risk in that canyon. Then we have a couple residential areas, and we have some projects we're considering and are talking. We've made a couple presentations to the Municipal Services Committee, but they're not finalized yet.
Thank you.
And also, Renee, if I may, in addition to the highest risk areas that we have, another tier that we have is kind of the tier lower than that, but we've been doing a lot of studies and inspections in those areas and beefing up the system, basically putting larger poles, stronger poles that, and obviously for the past, I'm not sure if you heard, but for the past 2 decades or so, we've been using covered conductors in our system. which is, I mean, a lot of utilities after the state mandated utilities to produce a wildfire mitigation plan, they started contacting us to see how we do the covered conductors. So we've been way ahead of basically a lot of utilities in this area.
Thank you, Virgin. So at this time, there aren't any other questions in the chat or in question and answer. So I just want to remind everyone that you do have our attention, and you're more than welcome to put your questions in. There's also, if you are having a hard time figuring out how to type them in, you can also use the raise hand function. And what we can do is we can unmute you and allow you to ask it live. So just give everyone a few moments. If there's any other questions that you have, or you want to raise your hand and provide comment or feedback, you can do so at this time.
Renee, I've seen a question that I think from Mr. George Vine asking about he did not see the EV charging stations in the capital budget. We
Good
do.
catch.
Maybe we did not see it specifically here, but we have a budgeted, if I'm not wrong, that's about $1 million or more per year. No?
I think it's about $3 million a year.
Okay. Well, so I can't remember the number, but yeah, we have a budget for the EV charging stations.
Thank you, Burhan. I'm glad you caught that. All right, I don't see any other questions. We do also, I just want to let everyone know, on our website for this project, which is pwpweb.com/PDMP, we do also have a feedback form. So if anything does occur to you after the meeting and you want to drop us a line or you have more questions, you can use that form and it'll get to us here and we'll be able to respond directly to you and answer any questions that you have. All right. Okay, if there are no other questions or feedback that come in, I think we will go ahead and end tonight's meeting. And on behalf of everyone at Pasadena Water and Power, we just want to thank you for taking the time tonight to give us your attention and be part of this process. It means a lot to us. And as a public utility, we always appreciate our community's involvement.
Thank you so much, folks.
Thank you.
Thank you.
Everyone.
Thank you.
Thank you.